Hello class, it's Mr. Kablan once again, and I'm here to present the final lesson for Chapter 8 that deals again with one shape, but two formulas. So we'll be dealing the one shape with the sphere and the volume and surface area of a sphere. So let's just take a look at the formula sheet again, and notice that again the sphere is the second shape on the right hand side there, and we'll be looking at both the surface area and volume. Okay, so just have it handy as we're going through these questions here. All right, so let's get straight to it. So when we're looking at a sphere, it's a very familiar shape to you because anything that's shaped like a ball, for example, a basketball, as you can see, a volleyball or any type or a ball-shaped object, okay, that's an example of a sphere. So when we're looking at a sphere, as I said before, we're not. I don't want you to confuse this with a circle because a circle again is two-dimensional, whereas a sphere is three-dimensional here. So a sphere is a round ball-shaped object. Okay, and what we just have to know about a sphere is that there is a radius that goes from the center of the sphere to the edge of it. Okay, and the formulas for that is for surface area it's 4 pi r squared. Okay, and again the radius is from the center of it and to the edge. Okay, in the event that you have a diameter, okay, don't forget that you would need to take the diameter and divide it by 2 in order for you to get a radius. Okay, so that's the formula for the surface area. Now I want you to pay very close attention to the formula for the volume here. And for the formula for the volume of a sphere, okay, it's the only formula that you have for all the shapes that has to have that actually has a cubed as one of the parts that in the calculation. So if you take a look at the r here, you notice it's r cubed and not r squared. So just be careful when you're putting it in the calculator there. All right, so that's basically it when it comes to surface area and volume. Okay, and what we're going to look at in this example as well is just another example of three-dimensional composite figures when we're dealing with volume. So we're going to see a shape and another shape and think of a strategy how we can solve for the volume using those two shapes there. All right, so we're going to see all that. All right, so first things first, we're going to start off with basic calculations looking at surface area and volume of a sphere here. So you can see what we have here is a regular sphere with a radius. So we're just going to put the r here, which in case here is 7, okay, and put it in for the r. Okay, and if you put that in your calculator, you should approximately get 615.44 square centimeters. Okay, volume. And as I said before, this one you have to be just a little bit careful because the r here, okay, is cubed. Okay, and when you do that, you should get 1,436.03 cubic centimeters. All right. Okay, so that's dealing again with the basic calculation for a sphere here. And as I said before, when you are given diameter, okay, the only thing that you have to do here again is just make sure you take the diameter, which in this case is 12, okay, and divide that by 2. And in this case here, the radius here is 6. Okay, put the numbers in, and that gives me 452.16 square meters there. All right, and for the volume, again, same thing. We're going to put in the 6 in for the R. You're going to cube it and do all that, and then that's going to give you 904.32 cubic meters. All right, so again, when you're looking especially at volume, just be careful that you are cubing it and not squaring it, whereas in the surface area you are squaring the radius there. All right. Okay, so that's a basic calculation for surface area and volume. So the next set of problems just require us to just dig deeper into the question and see what we need to write here. So in this case over here, okay, what we have here is a soccer ball. And it says, according to answers.com, the surface area of a soccer ball is approximately 1,600 square centimeters. And what we want to do here is to find the radius of the ball. Now, in this question over here, as I mentioned before, we are not solving for surface area or volume. However, we are going to use one of the formulas to help us solve this problem here. Now, when you're given a word problem, always read the question again to see what information is provided for you, to see what formula you need to write down. So if you read the question here, it tells you the surface area. So since it tells you the surface area, okay, the first thing we need to do is to write down the surface area formula for the volume of the sphere, okay? So the next thing we want to do here is to now replace the 1,600 in for the surface area. Okay, and then from here, we're going to solve for the radius. Now, remember that the radius here has a square attached to it. So that step where we take the square root will be the last step. So just keep that in mind. So the next thing we want to do is understand that we do need to isolate the r squared first. And the the pi and the r squared, okay, are grouped together by multiplication. So what we have to do in our next step here is divide both sides here by 4 pi. And that cancels out the 4 pi's on the right side. And what we have there on the left side will be 127.3885. Okay, and this is the step where you take the square root of both sides here. All right. Now, when you have the final answer over here, notice we started off with the surface area, which was 1,600 square centimeters. However, since radius is a measurement of length, okay, the 11.3 will just be centimeters here, okay? So when you're looking at the units, always see what units are given to you and what the final units are for this question over here. So radius, as I said before, is a measurement of length, so that's why the final answer there is just in centimeters. As I mentioned at the beginning of this chapter, the units are just as important as the numerical answer. All right, so the next example we're going to look at, okay, is we're now going to look at a composite figure here of two shapes here. And this time we're looking in 3 dimensions. And what we have here says a spherical object was placed inside a square box with sides measuring 26 centimeters. What we want to do here is to find the volume of the empty space inside the box, okay? So a good way to look at it, if you want to visualize this, okay, think of a box, okay, and you put a ball inside of it. So ask yourself this question: if I want to find the volume of the just the empty space, what would I have to do with the ball that's inside the box? All right. So I want you, as we're doing these calculations, just think of how we're going to calculate the final answer based on that. Okay. So step number 1 over here, we need to calculate the volume of the box. Now it tells us here that all 3 sides here are exactly the same here. Okay. So from here, the length, width, and height, okay, is going to be 26. Okay, and you're just gonna multiply those 3 numbers together, and that's gonna give me 17,576 cubic centimeters. Okay, and this is again when all 3 sides are the same. Okay, that's just gonna be called a cube. All right, so that's step number 1. Okay, step number 2, we now need to calculate the volume of the sphere. So by doing that, we have volume is equal to pi r cubed, 4 pi r cubed divided by 3. Now, remember that 26 is the entire distance across, which also applies to the sphere here. Now, the 26 centimeters with regards to the sphere is the diameter. So what we have to do to that is actually take that divided by 2 to get us the radius there, okay? So that's just one little tiny step that we have to just remind ourselves when we're dealing with anything that deals with circles, okay? And we take the 13, we're gonna cube it, and then multiply it with 4 pi and divide it by 3. And that's going to give us 9,202.78 cubic centimeters. Now, what I want you to see for this one here is now we need to now come up with a final step here. Now, as I said before, we want to calculate the volume of the empty box. So what would you need to do with the ball that's inside the box to figure out what the volume of the empty space is? Okay, now the empty space is assuming that the ball is still there, but when we're talking about the volumes, we've calculated the total volume of both of them. Now, to find out the empty space here, think about it as you removing the ball that's already there. So what we have to do in our final step here, just simply subtract the 2 volumes from each other here. So when we do that, we're going to take the volume of the box and subtract the volume of the sphere from it, and that's going to give us a total there of 8,373.22 cubic centimeters. All right. So that wraps up not only this lesson, but this chapter as well. So start preparing for the test by going through your review, and good luck on the test.